Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be discussing sediment dredging. Dredging removes sediment from the riverbed and reservoir pools mechanically, and it's done so to maintain navigation channels, remove sediment, environmental restoration, and a number of other purposes. What I have on the screen here is the web page in the 1D sediment transport manual that describes what we're going to be talking about in this lesson. And then also, if you scroll down here, there's a number of sub pages as well, the contents of which I will be covering in this video. All right, so let's go over to HEC RAS. I've got a model up and built and ready to go. We can access dredging by clicking dredging options here. Actually, let me go ahead and take a step back. I've got my model. Here are my files. I'm going to go ahead and click on Run, Quasi-Unsteady Analysis for Sediment. And then in this Options drop-down, Dredging Events. All right, I already have a dredging event that's been created here, so I'm going to go ahead and just delete that. All right, what I'm met with first is this message box that says create a new dredging event to specify dredging methods and so on. So to do that, what it's talking about is clicking this button up here for new dredging event. I'll go ahead and click that and then type out a name or paste in a name, click OK. So this dredging event is just going to be called Dredging Event 1. The other buttons up here at the top are for renaming your dredging event, deleting it, or copying it. Also, you can select different dredging events by the drop-down or the arrow buttons if you have more than just one. All right, next below that in this dialog box is the method. I'm going to skip that momentarily and come back to it. What I want to talk about next is the start and end date time. So we put in the start time of the dredging event in the first box right here. I'll say January 2nd of 2020, and then the time will be at midnight. Now, the second date time, the end date time is optional. If the end date time is left blank, then dredging occurs instantaneously. But if you add a date time in here as well, then the dredging event would take place during the difference between the start and end. So I just said the first 3 hours of January 2 here. Okay, so now let's talk about the method of dredging. And I saved this one a little bit later because whatever method of these 7 methods you select, it will affect the table data requirements further down here. Okay, so I can go ahead and read them off. Left station, right station elevation. That's the first one. That's the default. Below that, we have center station with elevation. And then below that, it's with elevation. So these first 3 options here for the method are based on elevation. You can just see it says elevation, elevation, elevation. And then the last 4 through 7, are based on mass. So you see mass, 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 and mass. Okay, so there's a lot of overlap between these methods. These aren't completely unique and distinct ways of defining the erosion method. So let's go ahead and just do an example of this first one, and I think it'll become clear how this works. What we want to do is select a river and select a reach. So I only have one river and reach in my model right now, so that's default, that's fine. And I have a cross section at every 100 feet along the river stationing. So let's say, for example, we want dredging at river station 600 and 500. So I'll come to river station 600 here. Now the left station and right station are the extents of the dredging. So let's open up our cross section editor real quick. Go to the cross section at river station 600. Say we want it to be from 150 to 200 as our left and right extents. Also, the invert would be 30.6. So let's say the elevation is maybe 2 feet of dredging. We'll put it at 28.6. All right, back to our dialog box. I'm going to type in 28.6. That's the new depth. And then for the left station, 150, and the right station, I'll say 200. All right, if I want to do the same thing for this river station 500, I can just go ahead and type in the same values, or I can just highlight the values, click set, and then type 150. It's a little overkill, but if you had a lot of records and you wanted to populate a number of fields or add or multiply a number of fields together all at the same time, then using the the buttons up here can help you save a lot of time. All right, let's go ahead and 28.5. If you want to set it to the invert, there's this button that says copy invert, and then it automatically copies the invert value 30.5 into the field for elevation. Okay, for whatever selected field cells. Let me try this real quick. Okay, so whatever, yes, selected fields. I'm going to go ahead and change this back to 28.5 though, so we're going to be dredging out 2 feet. These elevation methods, these first three here, are usually used for navigational dredging. This is when a watercraft requires a certain depth to traverse the waterway. These methods superimpose a rectangular template on the cross section and remove all the material within. If I head over to the user's manual and I select on elevation methods page, then once that loads, we can see the user interface. And then this diagram right here is a pretty good one. What we're doing is we're defining the left station, the right station that's of the cross section, as well as the elevation right here. So any of the material in the cross section that is within the extents of this red dashed line will be removed. So figure B down here below shows the results of that dredging. We have the original cross section minus the material in the green hatching here that has been removed. Okay, so let's go ahead and go back. The other elevation methods are center station with elevation. So what we have to do here, actually, let me show you the third one first. With elevation, what we do here is HEC RAS assumes that the dredging will be centered at the center station. So for that cross section at River Station 600 right here, the center station would be 175. So that's automatic. And then we would just specify the width. So let me go back, and all we need to do is specify the width here. So last time the width would just be 50, and then the elevation here would just be the same. So I'll just leave that at 28.6 and 28.5. Now the last method is similar to this. We'll specify the width, but we also specify the center cross-section station. So that is center station width and elevation. So if we wanted to keep this the same as before, I'd say 175 here. Oops. 175, and then here I'd say 175. Okay, but if I wanted to change the center station, I can do that by modifying the value in this left column. All right, let's go talk about the mass methods. The first one here is left, right, mass, prism. And just like before, we have the left station and the right station. That right station doesn't make sense at 50. Okay, I got that switched back, and then let's change this back to 150. But instead of specifying the elevation in this far right column, what we would specify is the mass of sediment that's going to be removed from each of these two cross sections. So right now we're not dredging any of the cross sections from River Station 700 upstream or from River Station 400 downstream. It's just at these cross sections at River Station 500 and 600. We could be making edits at other cross sections though. These mass methods for dredging are typically used in mining if a specific permit requires a certain mass can be removed. So for instance, you might not know what the elevation is, but you know how much mass of sediment that needs to be removed. That's when HEC RAS can go ahead and use one of these mass methods and then do the math and calculate what is the new elevation. So you don't have to know the exact final geometry, you just need to know the mass. Using this prism method, see, two of the mass methods are say prism and then two of them say veneer. The prism method refers to using a rectangular cross section, and then the veneer refers to taking all the station elevation points and then equally dropping them down to match the required sediment mass removal. So let me go ahead and just bring up the web page again about this. Here's the mass method. This diagram here is pretty good. What we have for B and C are the two mass methods. Where we have left right mass prism and then left right mass veneer. For B prism, it just here's the diagram here. It's just this solid line, so it's sort of a rectangular shape. But for C, it's actually going to take into account the different dots, the different station elevation locations. Line C right here, you can see like each of these data points drops about 5 feet on the diagram. So it still seems to maintain its shape. It's probably a more natural way for the sediment to be removed. That way the cross section still has a similar shape to what it did before the dredging began. Okay, so let's talk about the veneer method. So if we go left, right, veneer, the data input is just the same as before, but like I showed you, it's not a rectangular, it's a different methodology of removing the volume, or rather the mass of sediment. This veneer method preserves the station elevation points in the general shape of the cross-section by dropping each point the same amount. All right, so that's how that works. And then we also have a width mass, both prism and veneer. So if we do that, we would specify the width. This assumes that the dredging is centered on the cross section, on the center of that cross section river station. Last time I think I put a 50 here. It could be 50, it could be 100, it could be 200, but it will be centered automatically. And then again, you'd specify the amount of mass to be removed from each river station cross section. Now, say for example, you had a ton of different cross sections here and you wanted to automate the data input for this last column, either the mass or the elevation. Let's go back to that first method here, left station, right station elevation. And let's say we want to dredge from river station 800 down to 500. So I'll select that range of cross sections from this two drop downs right here, 800, 500. And then what's going to happen is I need to specify the elevation. So I'll start with an elevation of 28. And if I want to set that 28 to these 1, 2, 3, 4 elevation values, everything's ready to go. I just click this button to apply dredging elevations to the selected range. And boom, there is the data. Now, say for instance, I wanted to apply a slope. So right now, this is just a constant value. I can click on one of these radio buttons and then project sediment elevation from the upper river station slope. Now, the slope of this cross section here is 0.1%. So it's just a constant slope. And you can look at the numbers here if you're not convinced, but it is. So let me go ahead and type in 0.1%, or as a decimal, that's 0.001. And since I'm starting from the upstream river station, that's going to be 28. And then it's going to go 27.9, 27.8, 27.7. So let me click that and confirm. And those are the numbers. If I did it the opposite way and I used 28 as the downstream, which is the 500 river station elevation, then I would just type in the slope here. It doesn't have to be the same thing as the channel slope, but that makes most sense to me. So then I would just go ahead and click the button again, apply dredging elevations, and now this is 28, and then it goes upward to 28.1, 28.2, 28.3. That's again just for the elevation column. It's not for the left or right station. That's if you want to project at a slope or no slope in the case of same elevation. There's also an interpolate tab here where you'd specify the downstream sediment elevation. And I believe I'm not sure what this first box is for. I wasn't able to get this working, but there does apparently seem to be an interpolate tool right here. At the bottom, there's a checkbox here. It says reintroduce part of the dredge load. So when you're dredging and removing sediment from a river, you may not be able to remove 100% of it, but you may be able to remove or dislodge some of that sediment so that it becomes suspended in the water and continues to float downstream. So it is technically removed from its original cross section. That is all taken care of and calculated in this checkbox here. So if you click reintroduce part of dredged load, you can go ahead and type in the percentage. So say 10% isn't dredged, but it is removed and it's again in the water and floating downstream. Or it could be 20%. It could be probably between 10 and 40%, I read, unless you're not trying to remove the sediment at all and you're just trying to push it downstream, in which case you could put 100%. Now, typically, some of the larger grain size classes will be less likely to be reintroduced or reentrained, is what it's called. It's easier to pick up gravel than it is silt or clay. So say we had this set to 20%, and then what you can do here is specify, so CM, for instance, is coarse silt. This means that coarse silt is the threshold particle size, and only grain sizes smaller than the selected size, coarse silt, are eligible to be entrained. Particles this size and larger will be dredged and removed. So that's how that works. Also, you can set the river station where that re-entrained material is deposited, and you can go ahead and select it right here. Okay, so click OK. And then let me go ahead and add some data back in here. Just go ahead and set that to 200 and OK. All right, well, this is our dredged data. So I'll click OK. We now have that saved. We go back to my sediment transport analysis. This is the quasi-unsteady flow data. Once we have dredged data saved, we can click on dredged events again to see it again. And we have this check mark here to remind us that we do have dredging happening in this simulation. So let's go ahead and check to make sure our data is still there. And it looks like it is. That's good. Again, we can go ahead and copy and rename, delete, and click on a new and select a new dredging event. But currently, this is the one that we have set. So this is the one that will run with our simulation. All right, so once you go ahead and click compute, you can come up to the view menu and then sediment output. Now, haven't actually ran this particular model, so I'm just going to show you some results from the user's manual in the dredge output page. What you do is you select a variable here, such as volume dredged cumulative. This would be the cumulative amount of volume of sediment that's been dredged. And then you could also use mass, not volume. So there's different options there. Then you'd select your river and your reach. And then in the main display here, you could select plot or table, and it would show you either the plot or the table of the cumulative dredged material during the simulation. And this right here is the distance along the main channel. Yeah, I mean, if it's cumulative, it should probably keep going up. I'm not sure. This looks more instantaneous to me, but okay. All right, well, I'm still learning myself, so we'll figure that out. But anyway, that was it for this lesson. We talked about dredging, and as part of a sediment transport analysis, you go up to the options menu, click on dredging, specify the dredging data that you want, click OK, compute the simulation, and then view the results.